Hey everyone, we are doing number 36 on page 690. It's the review for chapter 10. I've already done the problem, but we'll just walk through it. So we have the equation r equals 2 plus cosine 2 theta, and r equals 2 plus sine theta. Below them, I graphed them out. So with the 2 plus, we've shifted up our curves for each of them, because they're both plus 2. For the cosine 2 theta, we actually changed our period. So our period is actually just pi because of that 2. Period for sine is still 2 pi. So it's all centered around the 2 mark. Neither one is ever negative, both positive curves. This is what it looks like once it's graphed on a polar plot. So we've got this shape here is our 2 plus cosine 2 theta, and then this circle is our 2 plus sine theta. And you can kind of see that from following the curves. We start at a 3 for our first equation. The radius slowly gets smaller until it gets to 1. It gets to 1 at pi over 2. Then it gets bigger again and hits 3 once it's at pi. And if we kept this going for a second period, it would do the same thing, but then just on our next set of angles. So getting down to the 3 pi over 2 and then bringing it back to the 2 pi. Now for our 2 plus sine, and we're starting at 2 right here, and we slowly get bigger until we get to pi over 2, which is our max point. That's at 3. It gets smaller again, probably a little hard to tell in this picture, but it gets smaller again until it goes back to 2 at our pi mark right here. And then it gets to its smallest point down here at 3 pi over 2, which is just 1. And then it gradually gets bigger until it hits that 2 mark again at 2 pi. So this is our graph of the two equations. And we were looking for the area inside this equation, but outside that equation. So I went ahead and shaded in that area, which are these two spaces here. Now to start, the best thing is to find our points of intersection. So we intersect right here, and right here. This is close to scale, not exactly, but we'll go through and calculate it. So essentially to find the points of intersection, we set these two equations equal to each other. We've got the 2 plus cosine 2 theta equals 2 plus sine theta. I've got 2 plus on each side, the addition of 2 on each side, so those cancel out. We just have the cosine 2 theta equals sine of theta. And we know from our trig identities, cosine of 2 theta also equals 1 minus 2 sine squared of theta. And so if we change that to that, now we've got everything in sine, which can be a little helpful. If we move all of that over to this side, we get 0 equals 2 sine squared theta plus sine theta minus 1. Now this we can actually factor out. And we get 2 sine theta, sorry about that, minus 1 times sine theta plus 1. And since it's polynomial, both equal to 0, we can set equal to 0, so we do 2 sine theta minus 1, set equal to 0, you move the 1 over, divide by 2, you get sine theta equals 1/2. For this one, we do sine theta, you just move the 1 over, so sine theta equals minus 1. And that finds where either one of these is equal to 0, which will then make the whole function equal to 0. And then for theta, we know that sine theta, thinking of our unit circle, is equal to 1/2 both pi over 6 and then 5 pi over 6. So our first quadrant, if we're thinking over here, and then second quadrant over there, because it's sine, so positive up here. And then for sine of theta equals -1, that's going to be theta equals 3 pi over 2, so it's down here. And so if we look at these 3 points and then look at our graph, we can see all 3 points of intersection. Now, to find the area, we know that both of these curves are symmetric across the y-axis. Looking at it, and even looking at our curves here, it's the same going down as going back up, going down, going back up. So we know that we just need to find this section and then multiply it by 2. I mean, we could try to do the whole curve, but we're going to run into a few issues, so it's easier if we just do this one section and then multiply it by 2. So if we set up our area equation, we know that we want the integral of 1/2 times one function squared minus the second function squared. That's to find the area inside this one, but outside that one. And so down here we've got our integral of 1/2 times 2 plus cosine 2 theta squared minus 2 plus sine theta squared, the 1/2. And since thinking ahead here and we're doing just this point, we know that this is 3 pi over 2, or minus pi over 2, and this is pi over 6. So we're just doing our bounds from there. Now the reason this is negative pi over 2 is if we did, say, 3 pi over 2 to pi over 6, we would actually be looking at this side of the curve. And we don't really want to do that. We're more looking just for this area right here. So that's why we're changing that 3 pi over 2 is equal to negative pi over 2. That way we're starting from down here and then moving our way up, rather than starting and going that way or going that way, which would just make it a little more difficult. So simplifying, we had the 2 times, since we're doing that piece and that piece, but we're just finding this piece first and then multiplying it by 2 to get both. So that 2 and the 1/2 are going to cancel when we get down here. And we squared these out. You got 4 plus 4 cosine 2 theta plus cosine squared 2 theta minus this whole function 4 plus 4 sine theta plus sine squared theta, all this with respect to theta. Now if we start simplifying a little bit more, we know that cosine squared of something is going to equal 1/2 times 1 plus cosine of twice whatever our angle was. So since in this case we had 2 theta, it's going to be 4 theta down here. And we do the same thing for the sine squared theta, except that's going to be 1/2 times 1 minus cosine 2 theta. So our angle is just theta up here, so it's 2 theta down here. Now, as we're simplifying this out, we also notice we've got a positive 4 and a negative 4, so those can cancel. We'll simplify out a little bit more. Multiply the 1/2 through from that trig identity trick that we did for those two functions, and we end up getting a positive 1/2 and a negative 1/2, and those can cancel out. And so we're just left with the integral of 4 cosine 2 theta plus 1/2 cosine 4 theta minus 4 sine theta plus 1/2 cosine 2 theta. We're taking the integral from negative pi over 2 to pi over 6 with respect to theta. Now once we integrate, it's a fairly easy integration. It's all addition, so we can do each piece on its own. Now the 4 cosine 2 theta is going to be sine, but we've multiplied by 1/2 because of the 2 inside. So 1/2 times 4 gets us the 2, so 2 sine 2 theta. Over here we've got the 1/8 sine 4 theta. That's because we had the 1/2 cosine 4 theta. Going backwards, we're integrating we get to sine, but we got to multiply by 1/4 because of the 4 theta. That's where you get the 1/8, 1/4 times 1/2. Now the 4 sine theta, pretty easy. We're just going to cosine. Remember, cosine of theta gets us a negative sine, so this has to be positive. Integrating, integration of sine is going to be a negative cosine, so because of the negative we get a positive 4 cosine theta. And with the 1/2 cosine 2 theta, again we gotta go to sine, but we're also multiplying it by 1/2 because of the 2 theta inside, so we get the 1/4, 1/2 times 1/2. And so this is our function, and we're taking it with these two angles. So once we plug these in to all of our thetas, this is the exact same function, so we plugged in pi over 6, 2 times pi over 6 gets pi over 3, 4 times pi over 6 gets 2 pi over 3, theta is just pi over 6, and then this is another 2 theta, so pi over 3. And down here we're plugging in the negative pi over 2, and we're subtracting this whole thing. So 2 times sine, 2 times negative pi over 2 is just negative pi, and then 4 times negative pi over 2 is negative 2 pi, and here we're just plugging in the negative pi over 2 because it was theta, and then for this last one we get a negative pi again because 2 times negative pi over 2 just gets us negative pi. And so this is what we need to evaluate to find the area. Now when we actually go through, to start, I'll actually go with just showing the bottom thing. Sine of negative pi, same as sine of pi, which is 0. So that gets canceled out. Sine of 2 pi, or negative 2 pi, is the same as sine of pi, which is the same as sine of 0. So that gets canceled out because that's 0. Cosine of negative pi over 2 is the same as cosine of 3 pi over 2. That's 0. That gets canceled out. Sine of negative pi again. That's the same thing as sine of pi. That's 0. That gets canceled out. So we're actually subtracting just 0. So we're really only concerned with this first part of that. So when we evaluate, sine of pi over 3 is root 3 over 2. Sine of 2 pi over 3 is root 3 over 2 again. Cosine of pi over 6 is root 3 over 2. And then sine of pi over 3 again is root 3 over 2. And we've got, our coefficients still there, 2, 1/8, 4, 1/4. And so just to make it a little bit easier, I factored out the root 3 over 2 because it's in all of our values. And then our common denominator here is going to be 8. So we've got the 1/8. So multiply everything by 8 to get up to that point. So we got 2 times 8 is 16, so that would be 16 over 8. We got our 1/8. 4 times 8 is 32 over 8. And 1/4. Just multiply that by 2 to get there, so we have 2 over 8. And so we got 16 plus 1 plus 32 plus 2 all over 8 times root 3 over 2. Once you add that up, that's 51. Once you multiply that through, you're going to get 51 times root 3 over 16. And that is our final area of, looking back at our graph, both of these sections, which is the area inside our 2 plus cosine 2 theta, but outside our 2 plus sine theta. Again, 51 root 3 over 16. Well, there's a shot of the whole thing. Hope this was helpful, and thanks for watching.